I'm the community director for COVESA. COVESA is an open global alliance for connected vehicles. Well, I'd like to introduce Thomas Spreckley. He's going to be doing the majority of the presentation. Again, I'll just talk a little bit about COVESA and then Thomas can take over. So we're open global, we're member driven really, members drive the projects. Projects are done within COVESA. It's a great place for collaboration. We have a vibrant ecosystem and we're all about open standards and technologies that accelerate innovation for the connected vehicles. So with that, I'll turn it over to Thomas. I'd also like to point out that we have a couple of other people who will be doing a demonstration, Eric and Sebastian, and there's a whole bunch of people on here I see who are experts who will have a question and answer at the end. Please speak up if you know you're one of the experts, you know who you are. So thank you.
Great, thanks for the intro, Paul. Welcome everyone, thanks for coming. This is going to be the first of what's going to be a quarterly series and event. One of the project that we're here to talk about today to give everyone, let's say, a high-level overview and then a quick demo is VSS. So Vehicle Signal Specification is what it stands for. It is a common approach for describing vehicle data. So simply put, what does it offer? It is a widely adopted, extensible data model and catalog with industry-supported tooling. VSS provides a common understanding across the value chain of the connected vehicle. So if we think now what value, some of the values that it brings, there are more we'll dive into later. Improved interoperability and integration from standardization is really the main thing here. So this ultimately, it helps save time and cost. That's allowing companies, you, to focus on business value creation and differentiating solutions. So this is like a really high level start, and I'll dive into a little bit more detail now. And Paul and I, we deliberately picked these two graphics because the two things from this slide where there is quite a bit of text, I appreciate, is we want you to remember that it's developer friendly and business friendly. So let's start at the developer friendly side. So it's simple, flexible, and protocol agnostic. It's a common approach for describing vehicle data, any vehicle as data. Extensible data model and catalog with industry supported tooling. We'll cover on that a bit later. I want to keep this high level for now. Can be used in the car, cloud, edge, or wherever you feel like you need it. I've seen some examples where people are using it with simulators, with games, vehicle driving games. It's really flexible, easy to understand and quick to use for machines and humans. So this is really all adds up to make it extremely developer friendly. On the other side of that, business friendly, and basically it's a common understanding of the data which helps to reduce and manage data silos. So we all know how we operate in the automotive industry. There are a lot of different data silos. VSS, this push for standardization, helps us to try and not necessarily reduce or eliminate, but help to manage and reduce. It enables improved interoperability and integration. We already discussed that one before, saving time and cost, as touched before, which also allows you to focus on your business value creation. It's widely adopted, and as Paul mentioned, free to use. So we shouldn't forget that last piece. So just quickly, VSS is not an API specification or an API. It is not a protocol. It is also not a serialization format or a service specification. And on the other side of here, it's also not a model for everything in the world. And I'm pleased that it's not, because that could get pretty unmanageable. It's also not an ontology. There are projects that are interesting there using VSS to create ontologies. It's also not an IDL, and it's also not limited to the car, cloud, or edge, as we discussed earlier. It's an open source standard, and there are many implementations built around it and on top of it. So, you know, you as the community are very creative. So get involved to dig deeper. We don't want to focus on these things now. Maybe in the Q&A, we have the experts, quite a few of them here on this call today, who are behind VSS on a day-to-day basis. So why now? These two illustrations, I think, kind of help to sum it up. I'm going to give people a little bit of space and time here to take this in because it's a pretty busy slide. But essentially today, the picture on the left, we have very, very high integration efforts. Any automaker or tier that's in the call, you all know this. It's very complex and often quite unmaintainable. So the current reality, I mean, these numbers, you can dispute them. These are taken from various sources, but I want to focus less on the actual numbers and more on what we could move to on the right-hand side. So VSS and a consistent interface, aka the API built on top of VSS or using VSS, really helps to reduce the complexity and the integration effort, and promotes the focus on the value, these operations services on the right-hand side here, rather than spending all your time essentially mapping and doing conversions and integrations to make these work, as you can see on the left side. So we come from the current reality. The challenges we see today are these siloed data by organizations and different domains in organizations, or even in the vehicle. You can have many data silos inside of a vehicle. Complex integration and interoperability, again, this is probably something you'll get fed up with me saying, but it's good to drive home the message. And estimate that 80% of the time is focused on integration, and we only typically get to spend a very small amount of time then on the value, and it's very noisy, and it's often very complex and challenging and frustrating. So, yeah. So where we see it used today, we just collected a few slides and screenshots of different projects and initiatives. This is not everything, so I apologize. There are companies I see in the call today. If your stuff's not on here, again, reach out to me and Paul. The goal for this is that we do it once a quarter, and it is constantly evolving and changing. So where it's used amongst automakers or OEMs, if you like to call them that. It's used now in fleet management operations and systems. We have probably AWS and Geotab on the call, just to name a few. It's also, interestingly, you can see on this slide here, it's interesting from a road safety and from a vehicle to infrastructure and planning perspective. VSS is coming up in those types of calls at the government and legislation level even. Also, I guess you could say, I saw someone from ISO here. Also, the extended vehicle, I believe, is based partly off VSS. So other standards, also the current partnership we have with AUTOSAR and the Automotive Vehicle API. That again is another standard that is going to be using or leveraging, let's say, VSS for its own benefits and gains. So the slide that probably gets us in trouble because undoubtedly we've missed someone, so I apologize if we have. Paul and we did another double check on this last night, but yeah, I know how it is sometimes. We tried to pick really here the names of companies that are really actively using this today in solutions, in offerings or vehicles. So it's not something small. It has maturity. It's been going for quite a long time now. And with that, I would love to hand over to Eric, who I believe is on the line, to dive into more details about what it looks like and a bit of more of the technical side, but still on a high level. So thank you, Eric, over to you.
Yes. So just one moment, and
just tell me when you want me to jump to the next slide.
Yes, yeah. I will do so. So what this slide here tries to show, well, go back to the previous, yes, is that, well, the starting point of what is VSS as of today. Well, it is a tree of signals where it tries to find some form of logical location, or basically a unique name for everything, so that you have some data that is directly on the vehicle, like vehicle.speed. But if you want to have wheel data, you need to go from chassis to axles to wheel. That doesn't in any way say that in your actual system that you have an axle system that contains wheel systems and so on. It's more to find a unique path for everything so that you can use it as an identifier. If we look here at the example down to the left, here it's stating right transmission speed. This is a bit old. That signal in itself doesn't exist, but it shows the intention of what are the actual signals itself. And first, even if you call it signal, you should not focus too much on that it necessarily need to be an actual signal in whatever way you define a signal, because it is a data point in one way or another. We have three types of data points. We have attributes, something that typically doesn't change under one ignition cycle of a vehicle. That could be like your VIN, your identification number of the car, the color of the car, the tire profiles, that type of data that is relatively static over a long time. It could be sensors, something that reflects something that is typically changing more frequently, like what gear are you actually using, or what speed are you running on at in this time. And from a VSS perspective, it's normally seen so that users of the data cannot typically affect a sensor like vehicle.speed. It's a measurement, something that you read only. There will of course be someone that provide the actual speed, but you as a user, if you write an application, you typically only read it. But then we have other things like what is called actuators, and that could be like door information, if it's open or locked, because that is something which you as an application potentially could like to do, that you want to unlock a door. You want to have an app so that a car owner can control it remotely. So then it's an actuator, and it can be used both to actually request the door to be unlocked, to be locked, but also in the other direction to check if it can be locked or not. And if we just look at VSS, and the door locking example is quite good. VSS in itself doesn't say anything about how this request is sent to the vehicle or sent within the vehicle. It doesn't say anything about what actual authorization checks, security checks, other things. What VSS in itself says is only the metadata, like what we can see here in the example in the lower left corner, that we say that your drivetrain transmission speed is a sensor, so you can typically not set it. It sets the data type, that's a UINT16, and that is, unless you have a system where you want to represent with another type, then in VSS we expect it to be a UINT16. We expect it to be able to handle the values that exist between 0 and 65,535 as one. We also say that unit is kilometers per hour. And this is nothing that needs to be necessarily always be used when you transfer something. It's more like if you have a representation like in a database where it doesn't store unit information, then it's supposed to be kilometer per hours. If it in a certain protocol is sent as meter per second, or with scale, like you're using CAN-off and like some scaling and offsets, that's fine. VSS doesn't care about this as long as it's when it reaches an end application. It should expect to be able to get it as UINT6 and kilometers per hour in this particular case. VSS can also specify min and max values, and that is like a guidance, what value range is there. That is something that's normally not that much used in the standard specification as of today, because the minimum and maximum speed is of course nothing that is generic for everyone. Like most cars will not go over 300 kilometers per hour, but might be. And you have a possibility there in your deployment potentially to use this and use this min max as some form of value range checks in your API. It also includes a description that try to give a common explanation of it, and that is one of the most important part with VSS, trying to come up with what do we actually mean with something. Well, speed here might be relatively straightforward, but you could have other types of data like condition of brake pads, something like that, where it's not that natural what you actually mean by it, because each OEM might have a different view, and there the description we tried to have it so that there is as little ambiguity as possible there. If we look to the right, is that shows a little bit what is the flow of how you actually use VSS. Well, you start with a tree, you start with a data that you can of course use when you just have discussion, and we use, as we saw in the lower left corner, what we call a VSpec file, a form of basically a YAML file definition with some additional features to include files. But that might not be a good choice for your actual use case. So we have, as part of a COVESA project, tooling to take the VSpec file and convert it to YAML, JSON, CSV file, Frankie IDL, and there are some other tools that exist. All of them exist as open in the VSS tools repo. But still, that doesn't give you a real API. Well, potentially with the exception of Frankie, where it actually is an API, but in most of other cases, it's just taking the same information and transforming it to another format so that you can use it in your original format. We can take next slide there. Yeah, this is, I believe, more or less the same information we had on the previous one, so we can jump one more there. So what is happening here is this current version 3.0, it's actually now 3.1 and actually 3.1.1 because we release new versions around, let's say, 3 times a year, typically 1 major version per year, 1 or 2 smaller version, and a patch version if we find some minor bug that needs to be corrected. It's community driven, and what we do as part of the VSS project is maintaining the catalog and maintaining the syntax of how you can define it, because the actual syntax here is intended to be extendable, and it can be used in other cases. So even if we have a signal tree, you could use it for a totally different signal tree and use the same tools. You can add your own signals with overlays. We have added now some initial support to have structs there. Previously, it's been mostly primitive types and arrays that we have supported, but now we're starting to add possibilities to have types and structs defined. There is also a possibility to define instances, like if we take something like doors, if you look at the example on the lower right corner there, the VSS approach is that you define a branch door, and then you define instances, and the default one is that there are, like, say, typically a left and right door, and there are, in most cases, 2 rows, and you then get a full path there when you're going to open a door or check if it's locked, but you take vehicle.door.row1.left, something like that to address it. So, and that's the instance concept that is used for that, to be able to multiply signals that exist in multiple instances, but still not in any way related to how it's actually from a system perspective who maintains it. It's still just sort of unique identifiers. Did you have any more slide there, Thomas?
No, it's great. We managed to keep it within half an hour because I love to have plenty of time for showing, demo, and then discussion and talking and questions. Because we also have Adnan and we have many other experts on the line and companies that are using VSS. So for those who are new, now is a great opportunity to ask questions, things you're curious about, to us all. So Eric, are you or Sebastian, one of you is doing the demo? Do you want to take screen sharing?
It's me. I will take over. I just noticed that there was one question like how is seat nested under cabin? Is there inclusion of some sort? Yes. If I look at files today, we have the VSpec files that are, well, we maybe have 20, 30 something in the tree, and then we have an include possibility. So it would try, if we go and look into GitHub, that could actually be a sort of a good starting point to actually start showing something. So if I start sharing.
Yeah, you go for it. I had the GitHub open, but let's go straight in. I think that's great.
It looks great.
Can you share, Eric, or do you need any permissions or anything?
I need to click a button, apparently.
How unusual.
How unusual. No, I believe that it should be.
We can see the screen.
Yes, great. So this is the starting point where we're working on the actual core VSS specification. And inside here, we have various files. So if I go to something like on very top level, we have a vehicle signal specification, which then, when it concerns things like, I think cabin was mentioned, that we have a statement here that we want to have a branch cabin included, and it refers to a file, cabin.vspec. And then inside that one, which is located here in the cabin folder, then I think we will have the door signal here. So it's here inside cabin, we have doors and an include part. But once again, this is only how it's handled here on this in our current source format, the VSpec files. When we do the tooling, it typically will become expanded. So if I look at an example from the latest release, because what we do when we do a release, at least for the last one, is that we have all generated artifacts for the tools that we actively support and are, well, consider that they must work for doing a release. There we can, let's open that one moment. So taking a CSV as example, and let's zoom here to something that makes it here you can see the full paths that typically gets generated. That, for instance, if we go for the seat example, here it would typically be vehicle.cabin.c.row1.pus1, and then you have some, for instance, seat switches. And similar there is if you want to address doors or something like that. And this is one potential representation, but of course it's nothing that necessarily needs to be, because this row of giving a unique identifier works very well if you are handling it in the form of a key value system like a database. But if you have some other form of more advanced handle like ontology, it might be more interesting that when you actually have a seat, that you have some other method to find which actual seat that you're into. That was a short detour. What I would like to show here is a little bit more of, well, how is actually VSS used, or how can you actually use it? And I would like to say first that there is no absolutely correct way how you should use the VSS, because that is basically up to you. As we saw previously when it comes to the signals say that if it, for instance, speed, that should be kilometers per hour, so that unless you have some mechanism to specify that you actually send speed in meters per second, it's supposed to be kilometers per hour. But we access it, how you store it, totally up to you how you send it as well. I would like to show a little bit of one use case that we from Bosch are very involved at, and that is the Eclipse COVESA project. And the COVESA project tries to solve one potential use case where VSS is usable. And that is like, you have here at the bottom, like a vehicle, where you have what we call non-VSS data. And that could be, for instance, CAN, that could be some IP, that could be, well, some data that exists in some diagnostic system somewhere in your own format, in your own, with your own identifier. Something that is, for an outsider, more or less impossible to know how to access it. I mean, potentially cannot access it either. On the other hand, on the far top, what we call here an app, the idea here is that if you want to do an app that is potential to use in and reuse in multiple vehicles, could be either you want to use it on an actual mobile phone and access data in a vehicle, or that you want to have an app that runs inside the infotainment. Then you want that app to be reusable in different vehicles, and then you cannot use OEM-specific signal names. You then want to have some standardized way, and there we see VSS as a possible solution. So that, let's say, for instance, that you want to control how much of the windows are opened based on the speed of a vehicle, and do a fancy app for that. Then you could design your app using the VSS signals and specify that this is the data that I want, and design your logic, define it, potentially in requirements in your architecture model or whatever, and show this is how it's supposed to work. And with some form of integration, it should be possible to reuse it into multiple vehicles. There you have a bit of challenges, and that is, of course, that the actual data, if you want to open a window or read how much is open or get the speed of a temperature, it is here down in the vehicle internal data, OEM specific. And the COVESA idea here is that we have some form of providers that have access to these internal vehicle systems, know how to convert data, and they convert it into standardized VSS signals and standardized VSS data points. We have a data broker, which in the COVESA case as of today is basically an in-memory database, but it also have support there to handle like set requests, get requests, subscribe requests. It supports two protocols. It supports both Google RPCs, but it also supports a subset of this protocol. And this protocol, defined by the World Wide Web Consortium, is it's a standardized API on how to access VSS data using HTTPS, WebSockets, or MQTT. And we support in COVESA as of today the WebSocket variant. In COVESA we have also then a framework for authorization, because if you want to do something like this, like say open the window, you need to have some form of security related to it, so that, well, in the West, it should not be so that a criminal should be able to open the window in your vehicle. It should just be your trusted application, and potentially only if you have the user actually have approved that it has access. So that is what Sven is supporting in COVESA Data Broker. Looking a little bit more on how it potentially could happen, there's a partially different use case, but if you want to open the trunk of a car, the idea is that your application can send down a request here to that it want to open the rear trunk. It sends it down to the data broker as a set request. In the data broker, it is so that you have someone that controls if a trunk should be open, and that one subscribe to the target value of this. So as soon as it receives the open request, it takes it and it's a trunk control service, and then it might need to perform, like for instance, safety checks and other things, because we also try to abstract that away so that in the data broker, which typically run in a QM environment, we cannot take any responsibility for functional safety. We do not know if it's safe to open the trunk. So that's part of the trunk control service that receives a request. And maybe if you actually are driving at a high speed, it will refuse to open the trunk. And then nothing will happen. And here, both advantage and disadvantage of VSS is that it is signals. And that also means that you only get general replies here if an actual message was successfully received or not. So in this example, when the app sends down a set request, it will only get a reply if that request was successfully received and accepted by the data broker. It will not in itself get any information of if the actual succeed in opening it. So that it needs to do in a different way. And that is, you have a trunk feeder that reports the actual position of the trunk, and the application needs to subscribe to the actual position of a trunk. So the app using VSS, it sends down the request already before it's subscribed to it, and then it needs to actually monitor and see when the trunk has opened. And that could, of course, if it's for certain operations like moving a window, there could be a physical, it will not be instant. There could also, of course, be safety reasons, or that something is blocked, the window is frozen, or something else that prevents it from actually happening. And then the app needs to know what to do if it fails doing it, potentially informing the app user. If it didn't succeed opening the trunk within 5 seconds, it must say that, sorry, trunk wasn't able to open. From a technical perspective, and please, Tom, if I take too much time, please say that I should hurry up or sum things up. What is it?
You're good for now.
Yeah. So what is it that we actually have in the COVESA repos? Well, going back to this picture that we have, let's see here. In the Eclipse repos, and in one of our use cases, which I want to show a use case on where data, non-VSS data, is transformed or being available for an app. And in our use case concerns CAN data, which is a common use case. And I saw a question there briefly that how does the provider knows that there are providers? Well, a provider is, if it's going to publish something, it either connects to the data broker and sends in data one by one. If it wants to have data, it subscribes to it. But as of today, the data broker itself doesn't have a predefined list of these are the providers that exist, but it is dynamic. There will be the providers that are there. Of course, there in a real deployment, there would be authorization that controls who actually have access to provide data, so that not an attacker can provide a fake speed for any purpose. But that is, as of now, not included here in the demo. But of course, you need to have that type of control of who can actually provide data. So the way it works is that if we go and look in, now we are part of the COVESA feeders repo. That is one of the Eclipse repos. So, and for this use case that we had here, that how to get data from non-VSS up to data broker. we use as an extension mechanism of VSS to specify the mapping. In this case, this angle of a steering wheel. Is it to the left, to the right, whatever, where we use a DBC file that specifies all CAN messages. And we specify in a config file which DBC message are we interested in, how frequently do we want to update the data broker, because that is an interesting aspect, because especially if you look at CAN data that could be sent at a very high frequency, like multiple times per second, but potentially if you have an app, it's maybe not that interested in getting an exact update 50 times every second, and that could also exhaust your system or your bandwidth or your quote on how much bandwidth you are supposed to be used. So in this particular case, we say that we are only interested in getting an updated value every 100 milliseconds. And then we also have a possibility to have a transform. In this case, is quite easy, taking a float value and then adding a half and rounding it down. Could be much more complex. For instance, if you want to translate from a meter per second to kilometers per hour, or if a CAN value is a scaled value so that you need to add an offset and subtract or multiply with something. But with help of that and this information, we can, whenever we get this signal, we can do some form of throttling to see that we don't exhaust the system, and then we can feed data. And I would like to show a little bit of how this actually looks. And inside the COVESA, we have, as David, with data brokers, a Rust application. We're using different technologies to show possibilities. We have some parts in Rust, some parts in Python. We also have a C++ implementation still, even if that doesn't get as much attention as others. So that
5 minutes more, Eric.
Pardon?
5 minutes more, because then we'll have enough time for if there are any open questions.
Yes.
Sebastian has been a keyboard warrior.
Yes.
So he's answered most things as you would expect.
Yes, so that is good. So the way we use a data broker is that we have a data broker and we give as input a standard VSS file, so that the data broker knows what signals to accept, and so that it, for instance, could check min and max values. And in this particular case, it's using Google RPCs and starts listening to what actually exists here. We also have a client. This is a Python command line interface where you could actually interact with a data broker and perform a set of operations, so that you can see if, like in this case, try to, for instance, get value to get vehicle speed. In this particular case, it just returns a path. It doesn't say anything about value there because there isn't anything that has been set. But it has also a potential ability to set it, and if you set it and read it, you will get, now coloring here is a bit ugly, but you get the value, you get the timestamp. So this is actually what it has been sending it over here. And that is, well, basically a test client. The interesting part from a CAN perspective is that we have this DBC feeder that's supposed to take CAN data, and it also has a mode by default where it uses a recorded CAN dump. So if we start looking at what this actually does, is that it uses a mapping file, which is more or less the standard one, but with these added configurations. It checks that the data that it has in its configuration file actually exists on the data broker side. And then it starts repeating this replaying can dump in this case from a can dump file, and starts to process the can signal and starts sending it to VSS. And how can we check that this actually happened? Well, that is, for instance, now if we get vehicle.speed, bit difficult to see here. It's a different value at the moment. It's 0 because it hasn't started, but we can nothing else see that the timestamp here is different. So what's happening under the hood is that the feeder down here handles all can data in the can dump. When it comes, it filters on if it is a can message that we're interested in. It extracts the VSS data, it transforms it, and then it uses Google RPC and send it over here to the actual data broker. And on the data broker, you could do all of this, like get and set and subscribe. So that if this would be an application, well, then you would instead use, for instance, a Python library or a Rust library to perform this get and set subscribe that you want to do. So that is one way of how you could use VSS, and all of this at COVESA, that is Eclipse, so it's open source, free to use and free to join in, and you are most welcome if you would like to, well, contribute there. That's it, Thomas.
Oh, thanks, Eric.
Yeah, thank you, Eric.
So just quickly before the Q&A, let me just share again my screen, because I'll put a little bit of pressure on participants now, because I see we have over 60 people. This is open source, so we're transparent. So I would love it if everyone can just go onto the Menti. It takes 10 seconds. I'm keeping it super simple for this first one. Just on a scale of 1 to 5, can you please just give us some feedback of where your understanding is? And if you want to save it to the end of the Q&A, you also can, because I'm hoping we can get you all towards a fully understand. But it's anonymous, so please feel free to just be honest, because we need to make this better over time as we reach more and more people with the message of VSS. So let's get the slides back up. I guess if we want to go back for questions, let's open the floor. Do we have any questions from anyone? Or do we want to, we could go over, Sebastian, perhaps on some of the answers that you've been giving in the chat, but I think let's see if anyone has any fresh new questions. If we get desperate, we can always head to the chat.
So no questions.
That good. This is, but if you have no questions, at least just please use the Mentimeter, and then we can get a gauge for where you're at on the scale. And I see there's plenty more links on the chat. Paul, it's probably worth, we can chuck in a link to the COVESA wiki page now as well, right?
Yeah.
If there are people that, I know some people love to just research and get reading. I do. So let's find it. Here we go. We'll point you to that if you just want to start learning more.
So yes, and on the wiki you'll find that we have weekly meetings about VSS. They're on Tuesday mornings, West Coast time, Tuesday afternoons, Central European time. Many of the people who are in this call are in that call, and it's a very good place to see what goes on. GitHub, pull requests, issues is another way they track it. And just generally, you're welcome to reach out to any of us, me, Thomas, Eric, and ask questions as well. I mean, the goal here is to get people to understand what VSS is and ideally use it. And as Eric said, there are a lot of ways it can be used. And basically, you know, we're trying to show the usefulness of it and to get adoption in places where it is useful. So if you have an implementation that you'd like to share with us, please let me know. or if you see areas where it could be used or extended, please let us know. Really just, glad that you all came and looking for collaboration and input. So
There is 3 of the same links now for resources at a glance. So if anyone misses it, it's there. Cute.
So it looks
Oh,
like
we have a question coming in here, right?
given a different person in mind, drivers, given vehicle is more like another IoT device on top of everything that a customer has. Do you have a POV on how VSS will harmonize with Matter protocol? Anyone? I don't have a point of view on that myself, but I mean, ideally, where it's useful, it should be used. We have interacted with Matter briefly. We have not done a lot with them. Do you have a point of view on how that it would be used, Anthony?
No, I did not. It was just more of curiosity. Like the VSS and I think the first or second slide you guys shared about how the motivation behind it to reduce the complexity across various, use cases like, fleet versus government and whatnot. So this was more along, seems like, not drivers itself, but thinking about driver as a persona. Like this is going to be one of many other IoT smart devices they are going to be parking in their home. How is this vehicle now going to interact with other smart devices that they have, and how COVESA is going to seamlessly, integrate into customers' life is what I was wondering. I do not have a point of this. Yeah.
So that topic is coming up more and more regularly now, and we have some sessions at the upcoming all-member meeting about this topic. It's really, the way I see this topic is how does VSS relate to other, out of the car use cases, domains. Probably domains is a better way of saying it. Is comes up regularly, and seems like there should be some exploration into Matter and into, so EV charging is one area where we're talking about this. Power optimization would be another. There are others.
Yeah.
So yeah. So
You wanna
yeah, go
do you
ahead.
want to join in? I think Ted has raised his hand, right, Paul?
Has he? Sorry. Yes.
Yeah. A concrete example is sort of proof of concept. I see Adnan's on the call. Maybe you'd like to fill in a bit more, but using W3C Web of Things and the ontology from VSS, VSSO, well, Adnan can fill in it better, but they created, created a thing description to expose some limited fit functionality of their choosing for a vehicle, and was able to get IoT interoperability with it. Web of Things abstracts out the protocol piece, so you can. I bet there's some plug fest that they've done with Matter protocol. So I think we should probably reach out to them again, and we can probably plug in some things together instead of necessarily saying it out of a single protocol to maybe address them, or just show that these things can plug together. I think that might be a really useful thing to do again. Adnan, do you want to, not to put you on the spot, but you want to fill in a little bit more? Maybe not.
Sorry, Ted. Like I missed few.
Yeah, I was bragging about your proof of concept that you showed off. It was been a couple of years now, maybe even more than a couple. How you guys created a thing description for W3C Web of Things to do some IoT interoperability with one of your vehicles.
Oh, that was really long time ago. That was like 2018,
but, I mean,
like 5 years ago. But that was one of the options. Like, if I remember correctly, like what we did there was using the VSS and standardized API in combination with the ontology with the SOSA, and then we were able to combine it with the, dear God, what was that platform? Node-RED, I think, in order to actually like have this integration with the different IoT devices. So it was linked to the W3C IoT working group. Are they called like that?
Web of Things, yeah.
Web of Things, yeah.
And what they seek to do is, since there's actually a plethora of IoT platforms and protocols, Matter just being one of many, and it's able to bridge between different ones very well. So I would bet money that we could basically leverage that and interact with Matter.
Yes, and I would say that how you actually use it, like now I have absolutely no knowledge here of Matter as a protocol, but if you have a VSS tree, and if you want to use those basically like in another protocol or wrapped in another protocol, there are different ways you can handle it. One is like the tooling we have for Franka, that you can take VSS or a subset of the VSS tree and generate something that fits into some other protocol or API framework. It could also be so that we are having a lot of discussions with just making sure that there is a sort of a mapping on logical level, like if Matter, if they would like to define certain vehicle attributes and having it in their own files, that we at least make sure that there is a good and well-defined how the actual integration should happen. So there are a lot of different aspects, and if we see a use case, then we need to look at that use case and see how do you actually want to do it. But as Paul and Thomas said, there are a lot of discussions about this, how to move between different domains. Like if you, in a totally different context, get the vehicle identifier, how can you then start extracting data? Or if within the vehicle that you have information of one identifier of the nearest charging station, how can you then continue to get data for that charging station? But as well, VSS in itself today doesn't specify how you can extract everything. It just says that yes, you could add and have a signal that includes some form of identifier.
Sorry to interrupt you. I just wanted to, whilst we still have time, there was a fantastic question which I think benefits everyone that I would love maybe you and Paul or Adnan to go through. What is the process to contribute, propose new data inside VSS?
So let me say something really quick.
Curious for everyone.
Sorry, go ahead.
Yeah, please. I think this is what we should.
It's really simple. Join the project, come to the meetings, and propose it. I mean, that's a simple way of saying it. There's more detail on like how you can create an issue or a pull request. I'll let the other guys talk about it. But really, every meeting is open. We have a community calendar on the wiki. I'll post it here in a second. It's on the wiki. It's the first link, I believe. So join the meetings; they're open and get involved. That's the simple answer. Go ahead.
Yes, and what we can say is that COVESA as such doesn't have any paid developers, but it comes from member companies. So you could, the first part, if you're interested in having a question or something, add an issue to the corresponding GitHub repo. Even more, if you even wanted to get it up a bit more priority, come to the meetings. If you have time to do some sketches in potentially even a pull request, do that before you spend too much time. Of course, first discuss if it's something that the community seems to want. But in short, pull requests are always welcome, and pull requests are the best way to move it forward. We typically have quite lean process, but that's the common way. For instance, if someone wants to add a signal, is that add a pull request where you explain why this is needed, and then we see if other likes it. Normally, we continue growing.
Does that answer your question? So we're getting towards the end of the time. I would encourage everyone to please follow Thomas's link to the question.
Yeah, to the Mentimeter. I would love to get 50% at least, so we can have some data we can rely on. So I'm 5 people off. So to the audience, quickly go in, vote. I see people doing it right now, so thank you.
Yeah, and
it really helps us. Taylor.
If you have questions, please reach out to me. My name was on the invite. And we'll get you the right person who may or may not be me. Probably won't be, but someone like Eric or Adnan, or they're the ones leading the VSS project. If you didn't get that, they're the chairs, and so they between all of us will figure out how to answer your question. But we'd love to get you involved. So and we want to make VSS as useful as possible to the community. So yeah, thank you all for joining. Anything else before we close? All right. Thank you, everybody, and we appreciate your time today. And hopefully you'll have some questions and we can get you involved. Thanks. Bye.
Thanks all. Bye.